Assalamu alaikum. Today is the 25th lecture on software quality assurance. In the last lecture we were talking about design of test cases. This indeed is a very interesting and vast topic, and that needs to be investigated further in detail. And we'll start that discussion, we'll start that investigation in a little while today. But before we do that, let's understand what are the broad categories of software testing. This introduction will help us in understanding software testing, and when we talk about test cases, we will see that different testing techniques are used, and these different testing techniques are applicable in these broad testing categories. So there are three categories of software testing. Number one, it's general software testing. Then is specialized testing. And third is testing that involves the customers or users. So let's now talk about general form of testing. The general form of testing is concerned with almost any kind of software and seek to eliminate most common kinds of software defects. These defects include looping errors, branching errors, and incorrect output. And so when we talk about software testing, we usually talk about general form of testing. And this form of testing is applicable to all kinds of software. That is, we must have general form of testing in all the different kinds of application domains that require a software solution. So now let's look at the examples of general form of testing. The first is subroutine testing. That is, when we test subroutines, that is included or categorized as general form of testing. Then we have unit testing, we have system testing of full application, we have new function testing, regression testing is a general form of testing, and also the integration testing. So as you can see that all the application domains, all the software solutions require some form of general form of testing. Some techniques are used, or some activities regarding software testing are always performed on all application domains. Then we have specialized form of testing. They are more narrow in focus and seek specific kinds of errors, such as problems that can only occur under full load, or problems that might slow down the performance. Specialized form of testing also includes testing for viruses or Trojan horses. And so this is the form of software testing that we perform, and we also look at other application domains. And we talked about the applicability of testing in other application domains and other areas other than computer science, and those areas can be applicable in testing in software engineering also. So specialized form of testing is not included, is not applicable to all software products. Let's discuss the examples of a specialized form of testing, and they include viral protection testing, they include stress or capacity testing, then we have performance testing, security testing is an example of specialized form of testing, then we have platform testing, and if you remember, the Y2K testing was also performed, and that was also an example of the specialized form of software testing. The third category is where testing involves users or customers. The forms of testing involving users are aimed at usability problems and ensuring that all the requirements have in fact been implemented, because it is ultimately the user or the customer who can decide about the completeness of a work product, completeness of a software solution. So examples in this category are customer acceptance testing, then we have field or beta testing, usability testing, lab testing, and finally we have clean room statistical testing. These are the examples where user or customer can participate and their feedback is very important, their involvement is very important in the process of execution of software testing. So these categories that we have just discussed will help us understand who is involved in performing the testing, what are the categories of software testing, and when we discuss different test case designs in a little while, these test cases would then belong to any one of these testing techniques and testing categories. So let us discuss now the test case design. We left off the last lecture and introduced this very important concept of test case design, and we said that any engineering work product can be tested in one of two ways. Number one, knowing the specified function that the product has been designed to perform, and number two, knowing the internal workings of that product. And this is true for all engineering work products, not necessarily just computer programs. In the first case, the tests can be conducted that demonstrate each function is fully operational, while at the same time searching for errors in each function. And in the second case, tests can be conducted to ensure that they performed according to the specification and all internal components have been exercised adequately. That is, if we talk about software, that all the code has at least been executed once. We don't expect the exhaustive testing that all the possible permutations have been tested, but we at least expect that all the entire code has been tested at least once. In the first case, the testing is focused on the external behavior of the software or its various components, and we cannot see inside the components. That is, we are only given the external specifications. We only know what the function or what the work product or what the component is supposed to do, and we cannot see inside that component. While in the second case, testing is focused on the internal implementation, and we must see inside the component. So these are two fundamentally different perspectives on software testing, or perspectives on test case designs. These two categories or these two kinds of test case design result in two broad categories of software testing, or two broad techniques of software testing. The first is the black box testing, also known as functional or behavioral testing, and the second is white box testing, which is also known as structural or glass box testing. Let's discuss each one of them in detail. Black box testing alludes to tests that are conducted at the software interface level. It is a given that testers do not have access to the details contained inside the component. That is, they cannot look inside the component if they are performing black box testing. Black box tests are designed to uncover errors. They are also used to demonstrate that software functions are operational, that input is correctly accepted, and that output is correctly produced, and that the integrity of the external information is maintained. The concept of information hiding and encapsulation plays a role here. We are not able to, let's say by black box testing, we'll not be able to access those elements of the component which we should not have access to. And that's another thing that is tested by performing black box testing. A black box test examines some fundamental aspects of the system with little regard for internal logical structure of the software. In fact, a black box test does not have any clue as to how that component is implemented. It does not know the internal algorithmic details. It does not know the internal private data structures of the component that is applied, on which a black box test is applied. The inner structure or control of the application is not known or viewed as irrelevant for constructing test cases. So the test cases that are going to be built using black box testing technique must not depend on anything which is internal to that component. The application is tested against external specifications and or requirements in order to ensure that a specific set of input parameters will in fact yield the correct set of output values. And if the output values are not included are not part of the acceptable output values, then that indicates a failure. And that observation of failure will then be reported back to the people who are responsible for finding and correcting those defects. And so this is very different mindset from looking at the code, looking at the internal details of the component that is being tested. The black box test designers must not assume anything about the internal information, about the internal data structures, about the internal algorithmic details and the flow of control of the components that they are writing tests for. It is useful for ensuring that software more or less is in accordance with the written specification and written requirements. That is, black box testing is useful for ensuring. The simplest form of black box testing is to start running the software and make observations in the hope that it is easy to distinguish between the expected and unexpected behavior. How do we know an expected behavior? Because we have planned those black box tests and we have classified the possible outputs with possible input. So if an input range is used, the test planning should results that the output shall be in this form. If that behavior is not observed, that is, there is difference between the expected results and actual results, then that is an indication of the failure of the software, and that's an indication of the success of the software test. The example that I have just quoted you is an example of ad hoc testing, and it is easy to identify some unexpected behavior even in ad hoc testing, and that behavior is a system crash. With repeated executions, we can determine that the cause is really related with the software. And if that is done, then in that case, the information is passed on to the people who are responsible for repairs. It is very important to note here that the tests have to be planned and the test cases must conform to the requirements. This is the concept that we were talking about when we were discussing test principles, that all tests must be traceable to requirements. If the tests do not trace back to requirements, then how can we be sure that the results that we are achieving are accurate? And so this dependency that starts from the requirements and continues on to design, to programming and testing, and to further development, further activities in software lifecycle is proven once again. Another point that we have discussed here is that with repeated executions, we can determine the cause to be related to software. Then remember, we talked about software, the reproduction of software tests, and that we must execute software tests a number of times to be sure that the circumstances that have resulted in the failure of the software or the success of the software test is actually because of the software test. A system crash can happen because of a hardware failure also, or a system crash can happen because of other processes running on that computer also. And so just by getting the system to crash once when a software test is being executed, one cannot be sure that it is the software or it is the test software that has caused that system to crash. And so we need to recreate the situation, and we need to be able to run that software test multiple times to be sure that whenever this software is executed as a test, this range of input is provided, there is always a system crash. And with that confidence, level of confidence, we can report back to the people who are responsible for number one, finding the defects that cause the crash, and number two, repairing those defects. When we started the lecture today, I introduced to you broad categories of software testing. Now what I'm going to do is I'm going to list the black box testing approaches, and some of the techniques that we had seen earlier in the lecture today are repeated here because those it is the same set of testing techniques, but they were categorized in general form of testing, specialized form of testing, and testing categories where user is involved. But now we are categorizing testing techniques as either black box or white box. So what are the different testing approaches that can be categorized as black box testing? Number one is system testing of full application. Number two is new function testing. Number three is lab testing. Number four is usability testing. Then we have customer acceptance testing. Then we have field or beta testing. And then we have clean room statistical testing. These are the testing approaches or testing methods that can be labeled as, that can be classified as, or that can be categorized as black box testing. Let us now talk a little bit about white box testing. White box testing of software is predicated on close examination of procedural detail. Logical paths through the software are tested by providing test cases that exercise specific sets of conditions and or loops. So there is a sea change of difference in how, in what black box testing is and in what white box testing is. So in black box testing, we couldn't see inside the component, and in white box testing, we cannot proceed if we don't see inside the box. We depend on looking inside the box. We depend on knowing all the intricate details, minutiae of the component that is being tested. The status of the programs may be examined at various points to determine if the expected or asserted status corresponds to the actual status. And that is that while we are executing the software, we continuously monitor different variables, we continuously monitor different checkpoints, so to speak, and look at the values of different variables within that component. And this is very, very different from the black box testing. The test developer is privy to inner structure of the application and knows the control flow of the application. Without that, he or she will not be able to plan the test, will not be able to develop the tests that are going to test the internal structure of the component, or at least knows the control of the software. So it is very important that the person who is responsible for performing white box testing have access to the code completely so that he or she can develop unit tests. There's another interesting thing that you might have noticed is that white box tests therefore cannot be completed before component level design. And because at the component level design, we start putting in the algorithmic details of the software, and then that component level design is taken by the programmers to faithfully implement in a computer language. Once that process has completed, and if we are lucky, we can have inspections, and if we are professional, I would say, we have performed the inspections on them, then we can have software testing, white box testing on that piece of code. It is useful that the white box testing is useful for ensuring that all or at least most of the paths through the applications have been executed in the course of testing. And white box testing enables us to ensure that the coverage of the testing is high. As we had said before, that as soon as we start introducing conditions and loops in an application, and almost all programs have conditions and loops. Without them, the programs won't be interesting, the solutions will not be interesting. And so the minute we start introducing conditions and loops and branches in the software code, the possibilities of permutations start to increase. The paths within which control can flow start to increase, and the more complex the condition statements are, the more the permutations are, and more the number of possibilities increase as we increase the complexity of the conditions. So what white box testing enables us is that the programmer, the test developers can look at the software code and or the component level design and and develop test cases which will force the control flow to be passed to at least to all the branches at least once. That is our ultimate goal, that we at least exercise all the components, we exercise all the paths possible at least once. We certainly know that it is not possible to exhaustively perform software testing in a moderately sized, in even a moderately sized algorithm, a moderately sized software. For very simple getters and setters type of software applications, yes, exhaustive testing may be possible, but anything real for complex problems that require complex solutions, exhaustive testing is not practical. It is not possible because it is very expensive. It takes so long that the solution may be worthless if we choose to perform exhaustive testing. Using white box testing methods, software engineers can derive test cases that guarantee that all independent paths within a module have been exercised at least once. This is something I've said before. This is a little bit more formal. Test cases that exercise all logical decisions on their true and false sides. That is, I was saying that every condition has true and a false side, and the test cases should enable the program flow to exercise at least once on the true side and at least once on the false side. And if this condition becomes complex, then this true-false will not be only two options, and there'll be multiple paths depending upon the complexity of the conditional statement. The software engineers who are using white box testing methods can derive test cases that execute all loops at their boundaries and within their operational bounds. It is very interesting that when you're working with loops, there are three areas that are very important. One is when the loop starts and the numbers before that, or the conditions that exist before that. Second, within the bounds. Third, at the boundary on the higher end, or when you are completing the loop, and the conditions that make that boundaries that take you out of the loop. So you have the boundaries of the loops, and then you have the conditions that keep you within those boundaries. Test engineers must at least ensure that these three conditions have been, or these three situations have been exercised while writing white box testing. If I'm running a loop from 1 to 20, let's say, I don't have to necessarily run a test the loop from 20 to 19 on every step. That is, I don't have to test it for 2 and 3 or 4 or 5 and 6 and all the way to 19. Testing within that range once would be sufficient. But I need to ensure that the loop is not executed for 0 or for 21, or that loop is executed for at least 1 and 20th. So I need to test the boundaries, and I need to ensure that one path goes through the loop at least once. And that information, that sort of test case development can only happen if code is available. Similarly, test developers who are using white box testing can write test cases that exercise internal data structures to ensure their validity. And so if a data structure is used in a software program, that has to be initiated, that has to be initialized and used. And so the test cases will fill those data structures and see if they are valid or not. And that is the purpose, one of the purposes of, one of the reasons why we conduct white box testing, so that we can look at the internal details of the component. The simplest form of white box testing is a statement coverage testing through the use of various debugging tools. These debugging tools are commonly known as debuggers, and they help us in tracing through the program execution. Tracing means help us in going step by step when the program is being executed within the debugger, within the debugging software. By doing so, the tester can see if a specific statement has been executed and if the result or the behavior is expected. And that is what I was saying, that at certain checkpoints in the using the debugger, the white box tester can set certain checkpoints at certain locations within the code and see what are the values of different variables at that point, at that milestone. One of the advantages of white box testing is that once a problem is detected, it is also located. You don't have to go and find another problem. You know exactly where the problem happened. This may have been caused by some other factors, but the location of location where the problem occurred, and this is especially true if you are running debugger tools, that the location is identified instantly. However, problems of omission or design problems or design defects cannot be detected easily with white box testing, because if the information is not there, how can a white box test developer look for that? So the things that are omitted, or errors of omission, if you remember, are not easily detected by white box testing. Another important point is that the tester needs to be very familiar with the code, that the code that is being tested, to trace through its executions. Without tracing, you cannot, for simple functions, for simple units, you can have testing without tracing, but for complex and large units or complex units, you cannot have successful or effective white box testing without tracing them, if you're especially looking for defects. Therefore, typically white box testing is performed by the programmers themselves, because they are intrinsically, they know the intricate details of their software. They know the branching, they know the conditionals, they know the loops more than anyone else, because they are the ones who have created them. And so if they test if they perform white box testing, results have shown that these people, or the programmers, are the most effective in finding or conducting white box testing. We will talk about this at another point also in our course, but suffices to say now that white box testing is most effective when it is performed by the programmers themselves. Let's now talk about white box testing approaches. Subroutine testing is an example of white box testing. Unit testing, viral protection testing, stress or capacity testing, performance testing, security testing, and most famous Y2K testing was also an example of the white box testing approach, because we had to actually go inside the code and see if the date format is accurately recorded. There are few mixed testing approaches also, that is a mix of black box testing as well as white box testing. They are independent testing, regression testing, integration testing, and platform testing. This was our brief introduction on black box testing and white box testing. We will talk about different approaches within black box and white box testing in later lectures. But now let us have a comparison on black box and white box testing. It is the perspective which primarily distinguishes the black box and the white box testing. And we have, throughout the discussion up to this point, have talked about this fact, that the perspective in black box is very different from the perspective in white box testing. However, there are other criteria also that can be used to compare white box and black box testing. So now I'm going to start some discussion on comparing black box and white box testing. The first criteria is obviously the perspective. Throughout our discussion on black box and white box testing, we have said that it is the perspective, the viewpoint, that changes our thinking on how to test. If we want to test the external behavior and don't want to know or are not privy of internal details, we only use black box testing, or we use black box testing. On the other hand, if we want to look at the internal details and we want to test and to validate the data structure, the coverage of the component, then we choose white box testing. And so if we compare black box testing with white box testing with perspective, the black box testing views the objects of testing as black boxes, while focusing on testing the input-output relations or external behavior, while white box testing views objects as glass boxes, where internal implementation details are visible, and using that information, using those details, testing is performed. So that was the first comparison criteria. The second is objects, that is comparing black box and white box with respect to objects. Although objects tested may overlap occasionally, that is, some objects will be tested by both white box testing and black box testing as well. White box testing is generally used to test small objects, such as small software products or small units of large software products, while black box testing is used generally more for large software products and for substantial parts of the system as a whole. So here again we can see that the difference between white box and black box testing, there would be some overlapping, but generally speaking, the structures, the objects that are given to black box testing are larger. And going back to our test principles that we had discussed, we said that testing should start in the small and then proceed towards testing in the large. And we said that when we are planning tests, we should have unit tests in the beginning and then combine certain components to form clusters which will then be testing. And at that, using that principle, we can say that the white box testing is done earlier than the black box testing, because the size of the objects is also different for the two testing techniques. And that just exactly brings us to the next criteria, which is the timeline. White box testing is used more often in earlier sub-activities or sub-phases of software testing, such as unit and component testing and function testing, while the black box testing is used in late sub-phases of software testing. That includes system and acceptance testing. Also, when we are looking at when we are testing clusters of components, that also is part of, that is also done by using black box testing. So we have initially unit testing, which utilizes white box testing techniques. And when we combine these components to form clusters and overall system, then black box testing is useful and is applicable. If the criteria is defect focus, let's see how these two techniques fare. In black box testing, failures relate to specific external functions. And so when we are using black box testing, the failures in external functions are observed, leading to corresponding faults being detected and repaired. So the failures the focus of finding failures is at the external behavior level. The black box testing expert or black box test planner does not know the intricate details, the inside details of the component. And so they only can look at the external behavior that is available to them for software testing. And they develop their test cases to observe behavior, observe failure of software system that can be done through the external behavior. The emphasis here is on reducing the chances of if encountering functional problems by target customers. The idea is that since we are performing black box testing in late sub phases of software testing, in near future the software product will be given to the customers, and we would want to remove as many defects before we give the software product to the customers. Now, what is the defect focus for white box testing? In the white box testing, failures relate to internal implementation, are sought for, and once a failure is observed, the defects are identified and removed directly. The emphasis is on reducing internal faults so that there is less chance of failures, and it does not matter what kind of application environment the software is subjected to. So the focus is primarily on trying to find the internal faults of a component. These faults, obviously, if they are left in the program, in the code, would work together to create faults, or it will result in the failure of the software system at the system level also later on. If we consider defect detection and fixing as a criteria, the white box testing, and we are using white box testing, it is not a surprise that it is easier to fix defects identified by white box testing than black box testing, because of the direct connection between the observed failure and program units and implementation details in the white box testing. When we are using white box testing, we already know the details of the software component that is under test. We can fairly easily locate the defects and fix them. That is why, if you carefully look at the software development processes, the techniques that are using the techniques based on white box testing are applied closer to, in timeline wise, closer to development activities. However, white box testing may miss certain types of defects such as omissions and design problems, which can be detected by the black box testing better. So the performance of finding omissions and design problems is easier by black box testing as compared to white box testing. And in general, black box testing is effective in detecting and fixing problems of interfaces and interactions between components, while white box testing is effective for problems localized within a small unit. And that has been the theme throughout our discussion on these two techniques. Now, we had said earlier that there are a number of testing approaches that some of them fall within the category of black box testing, the others fall under white box testing, and some are interchanged, or some are mixed testing styles or testing approaches. In any software testing exercise, various techniques can be used to build models and generate test cases to perform systematic black box testing, and others can be used for white box testing with some of the same techniques. And so, as we said, that in some situations, some testing approaches will be included in white box as well as in black box, can be included as white box or black box testing methods. Again, the perspective will help us in determining if a technique falls under white box or if it falls under black box testing approach. A specific technique is a black box testing technique if external functions are modeled, while the same technique can be declared or can be classified as a white box testing technique one if internal implementations are modeled. And so, depending on the situation, depending on the need, the one technique can be applied to both testing methods. And there is this last comparison criteria, which is the tester. Black box testing is typically performed by dedicated professional testers and could also be performed by third-party testers, as we have discussed earlier, when independent verification and validation of the application is required. On the other hand, white box testing is most effective if it is done by the developers themselves. We will talk about this in some more detail in a later lecture. Now, before I leave this class today, I would like to summarize that today we have discussed primarily two testing approaches, that are black box testing and white box testing. We had a brief introduction on each one of them. We looked at the different testing methods that fall under these broad testing approaches, and in the end we looked at the differences from different perspectives. We will continue our discussion on software testing and software quality assurance in the next lecture. So what I suggest is that you continue to read the material so that you become familiar with software testing and software quality assurance. So I'll see you in the next lecture. Bye now.